That's full size. And section 2 deals with graphing. Linear equations. Don't worry about all the typos. I fixed them. I live life by the red line. Meaning that when I type emails up, I always type them in Word first. Oh wait, I'm on the wrong computer. That's why it's doing that. I always type them up in Word first, and then make sure everything's like grammatically correct and everything's spelled correctly and all that good stuff. Then I copy and paste it into my email. So here we go. Graphing, linear equations, and two variables. Okay? That's what we're talking about today. Now, excuse me, there are many ways to do this, but I think the easiest way is just to start off with something that we're familiar with, which is just creating a table. Okay? So, Dawn, did you asked for fractions, correct? All right, so let's start off with one. So here's an example. All right, so we're going to graph y equals 1/3 x plus 1, and then we're going to label the ordered pairs. Okay? So to do this, you need to create a table. How many points do we need to form a line? Any question or any idea?
Two.
Two. I agree, Sydney. You need at least two. But it's always good to have how many?
Three.
It's always good to have three. And the reason why we always like to do three is just in case you made a math error, you will be able to physically see, uh-oh, I made a mistake somewhere. Because it should form a straight line when you connect all the dots. So I'm just going to put a little star. We need three ordered pairs. Now here's our table. I put an X, and then on the right hand side, I label y equals 1/3 x plus 1. Other people will just do this. Other people will create their table and they'll make it look like this, which is fine by me as well. X and Y, I don't care. Personally, I just like to see the equation on top. That is 100% my little thing. Okay? Now, Dawn, since you asked for this, I'm going to ask you a question. What is the one thing that we don't like about this equation that I gave us? I mean, there's a number in there that I'm just like, oh, why did he do this? What is that number? Well, you asked for this type of problem. It's a fraction, correct?
This is why.
Yeah, this is why. We don't like the fraction.
Is it the one?
It's the 1/3. I don't like the 1/3. It's a fraction. So when I pick my x values, I'm going to be really, really, really careful about what x values I'm going to pick. So I'm going to give you a hint. The first x value I'm going to pick is -3. Now, can somebody answer this question? Why did I pick -3?
Because it's in the same multiple as the denominator and the fraction.
Bingo. See, when I come across a fraction and I'm asked to pick x values, I can pick any number I want. I could pick 2, 18, 40,000. Doesn't matter. However, since I have a fraction, my eyes go right here to that denominator, and I'm going to pick multiples of 3 because I know I'm going to have to divide by it. So I'm going to pick -3. Dawn, give me another x value. And make sure it's a multiple of 3.
6.
Love it. Somebody else, give me one more x value.
12.
I love it. So we have -3, 6, and 12. Now, we need to find the associated y value. Because remember, these are ordered pairs. They always belong together. And I got to say this, I am preparing you for something later on by the way I'm saying this. When x equals -3, what does y equal? Now, you're going to hear me say that a lot, and I'm preparing you for this thing called functions later on by me, talking in a very specific manner. So, what we're going to do is we're going to go ahead and find when x equals -3, what does y equal? So, I can rewrite -3 as -3 over 1. 1/3 times -3 simplifies down into -1. So we have y equals -1 plus 1, which is y equals 0. So my first ordered pair is -3, 0. Does that make sense, everyone? All right, good. Now we just literally moved down the list. So I'm just going to erase and put a 6. See, in the previous section, I gave you the x values. In this section, you're telling me what they are by picking numbers out of your head. Doesn't matter what they are. So, what's 1/3 times 6? Anybody know?
2.
Perfect. So this is going to be 2 plus 1. Now, let me show you why real fast. Let me show you why really quick. 1/3 times 6. I'm going to rewrite that 6 as 2 times 3. And the reason I did that is so I can take this 3 in the denominator, that 3 in the numerator, and scratch them out. Look what's left over. 1 times 2 is 2. And 2 over 1 is just 2. So that's how we got that 2. So 1/3 times 6 is 2. And 2 plus 1 is 3. So when x equals 6, y equals 3. So this is going to be the point 6, 3. And now for the last one. When x equals 12, y equals 1/3 times 12 plus 1. Well, 1/3 times 12 is 4. And 4 plus 1 is 5. Okay? So we have our 3 points. Now here comes the fun part. Notice I'm switching over to my graph paper because I am terrible at graphing things by hand. And the reason why I'm terrible is because I'm sloppy. So I'm going to go ahead and just draw my rectangular coordinate grid. I'm going to plot these points, and hopefully they're all in this. They all follow some sort of straight line pattern. So the first one is -3, 0. So that's going to be right here. Give me a second here. I got to label all this stuff. Is my handwriting okay? I'm not looking at the screen, so if you're shaking your head, yes, I have no idea.
Yes.
Okay. Thank you.
Yeah.
All right. Second point is 6, 3. So that's going to be like right about here. You know what? And I'm sorry, I'm not even labeling them. I should be labeling them. And then the last point is 12, 5. So I think that's like right about there. So visually, does this kind of look like it's a straight line? So do I feel pretty confident that my answers are correct?
Yes.
Absolutely. That's all we're doing right here.
Okay.
Okay? Now, I do have to be honest with you. Once I found my points, I would probably just use Desmos because the computer is better at drawing straight lines than I am. It's just a fact. Okay? Are there any questions so far? All right. So now I want to go over two special lines.
So I think the part that I had trouble with is I tried turning it into standard form first.
Oh. Wait till section 3 for that. Okay? Because there's something we're going to learn in section 3 that when you put it in standard form, graphing becomes super easy. Okay? So the two special lines I want to talk about are horizontal lines and vertical lines. Now notice I have a space here, okay? So make sure you put a space. Because these are very special. All right? They're very special. All right? So let's start with the horizontal line first. So I'm going to draw this horizontal line right here. And notice it's like perfectly flat. It's horizontal, okay? And there's something really interesting about that line. Can anybody tell me? Now, what you need to do is think about what did we learn so far about lines? We've learned tables. We've learned infinitely many solutions. We've learned ordered pairs. We've learned how to determine if the ordered pair is a solution. I mean, you learned a lot. But there is something very special about this. Anybody tell me what it is?
It only crosses the y-axis.
It only crosses the y-axis. Wesley, I kind of like that. Kind of like that. What else?
X is 0.
X is only 0 at one point. It's right here. So that's the point 0, 2. I didn't say that wasn't bad. I didn't say it was good. In fact, I would say that is good. I like that. What else? I mean, there's something very special about this. Dylan, help us out. Can you tell me what this point is?
2, 2.
Let me see who else can I pick on here. Somebody with no camera on. Uh-oh, now the pressure's on. How about Brendan? This point right here that I just drew. Can you tell me what that point is?
That'd be 1, 2.
Oh, be careful. It's on the left-hand side.
Oh, negative 1, 2.
There you go. That's okay. That's okay. Now, there's something very special happening here. Does anybody see it?
All the y values are 2.
Say that one more time and say it loud and say it proud.
All the y values are 2.
Look at all the y values. It doesn't matter what x value I pick. Hallie, thank you very much for that. It doesn't matter what x value we pick. Y always equals 2. All horizontal lines have the equation y equals some number. In this specific situation, this is the equation y equals 2. And it's because I don't care what x is, y always has to be 2. So if you were to create your XY chart and you were to pick 3 random X values, let's say -1, 0, and 2, I don't have to do any math. Because Y always equals what? Hallie. Perfect. So if I were to ask you this question right here, so I'm gonna move it over to the right. If I were to ask you to graph Y equals -4, there's no math. This is what you do. Just watch. Everybody just watch. Eyeballs up on the screen. Graph Y equals -4. I draw my rectangular grid. I go down 4 units. I put a little dot. And since I know this is Y equals -4, it's a horizontal line. Ramp, ramp. Done. Done. It's the easiest one. Home run question. It will be on a test. And it requires 0 thinking. All it requires is understanding. Y equals a number is a horizontal line. That's a freebie on a test. Freebie. Hallie,
3 of them, Ben.
3 of them? I'll give you 4 of them. I'll just make the test longer. Hallie, you're very excited about this one, aren't you?
I am, because I understand it.
It's easy. It's easy. Now, let's finish up the class with this one. What's the opposite of vertical, or what's the opposite of horizontal?
You just said vertical.
Vertical. Vertical. What's the opposite of Y?
X.
So, vertical lines look like this. Okay? And notice there is something very special. It doesn't matter how high or low I go with this line. All of my X values will always be what number?
3.
So, what is the equation of this line? X equals what?
3.
3. Therefore, all vertical lines have the equation X equals some number. So, if you see X equals some number, you got to be able to recognize, oh, that's a vertical line wherever X is. You just go up and down. Just like what we did with the previous example, which horizontal lines. So, let me give you an example. So, I want you to graph X equals -1. So, I'll give you a second. Go ahead and graph that on your own. And then I'm going to do the answer, and you compare. All right, we should be pretty much done with this one. So, I go ahead and draw my rectangular coordinate grid. Put an X and a Y. I'm going to start labeling a little bit. And since I want you to graph X equals -1, you go over to where X equals -1, you put a little dot. And because it's X equals, we know that is a vertical line. So I go up and down. Call it a day. So, at the end of the day, here's what we did today. If I give you a linear equation in 2 variables, let me scroll up. If I give you a linear equation in 2 variables, like y equals 1/3 x plus 1. And I told you to graph. You got to create a table of points. And then you got to graph them, connect the dots. Good?
Yeah.
Perfect. Now, we looked at two special cases. Notice they're both linear equations. This y equals 2 thing is linear because the y is raised to the first power. So it is linear, but it's a very special line. It's a horizontal line. Lastly, I gave you this example right here, and I said, please graph x equals -1. And that is linear as well because the x is raised to the first power. However, it's a very special case because no matter what, x is always equal to -1. Therefore, it's going to be a vertical line. We are no longer talking about a number line in left and right anymore. We're no longer in one dimension. Now we're in 2 dimensions. We have an x and we got a y. And they always exist as an ordered pair. Good? All right. Well then.